Hi, welcome to this video. Today's video we are going to evaluate this integral set as I equal d phi over 4 plus 5 cosine phi. This is trigonometry function inside of our integral. When you see the function has trigonometry, you may use substitution as variable change or switch our trigonometry into another forms of trigonometry like sine phi or cosine or tangent, something like that. Okay, so in our case we know sine phi equal to tangent phi over 2 over 1 plus tangent square phi over 2. We know second equation, which is cosine phi equal 1 minus tangent square phi over 2 over 1 plus tangent square phi over 2, right? I'm not going to prove this one. I will prove it later where we see more details. Okay, let's start evaluating our integral now. Let's put I equal d phi over 4 plus phi. We know this one, cosine phi equal 1 minus tangent square phi over 2 over 1 plus tangent square phi over 2. Why I'm choosing this formula? Because I know when you differentiate tangent, it gives you 1 plus tangent square phi over 2 with 1 plus tangent square phi over 2, where you see more simplification. You can reduce your form to the smallest one, right? That's our goal. So let's calculate this one now. I have I equals d phi. I have 4 multiplied by 1 plus tangent square, which is 4, plus 4 tangent square phi over 2. Let's multiply 5, this one. It gives you 5 minus 5 tangent square phi over 2 over 1 plus tangent square phi over 2. So this one, it gives us what? Let's put this one on the top. It gives you 1 plus tangent 2 phi over 2 over the whole thing. Let's calculate this one. 4 plus 5, it gives you 9. 4 minus 5 tangent square, 4 tangent square phi over 2 minus 5 tangent square phi, or it gives you negative 1 tangent 2 phi over 2. Okay, what is this? D phi. Let's make substitution now. Let's make t equal tangent phi over 2. Let's make differentiation now. dt equal, this differentiation gives you 1 over 2 of 1 plus tangent square phi over 2. Okay, d phi. So d phi equal what? D phi equal 2 times 1 plus tangent square phi over 2. Okay, dt. If you take a look at here again, you see 1 plus tangent square phi over 2 in the as a denominator. So the top one, you see, you can have simplification now. 1 plus tangent square phi over 2. You have 1 plus tangent square phi over 2. You can simplify that. That's our goal. That's why we are using this formula. Now you understand why I'm using this formula. Okay, so let's log in into our integral. I 1 plus tangent square phi over 2 9 minus t square d phi less 2 1 plus tangent square phi over 2. Look, you can simplify this one and this one. It gives you, let's take 2 outside. This is t5 always. Okay, let's take 2 outside as a constant out of integral. So our integral becomes d5 9 minus t squared. This is called substitution. We change our integral from phi to t, okay, in terms of t. This is called substitution. You change the whole thing, which was phi into t, in terms of t, okay? What is this? This is, we are not going to leave it like this. In order to be integrated, we are going to use the decomposition form, okay? Decomposition form, if you have, for example, 1 over x minus a multiplied by x minus b, it gives you, for example, alpha over x minus I plus beta over x minus b. We have to change it on this form, okay? This one, if you take a look at here, this is in denominator, you can put the 3 minus t multiplied by 3 plus t, okay? So our integral become 2 times d5 over 3 minus t, okay, 3 plus t. All right, so it looks like simple here. Yeah, so what is this? We can put it this way, 1 over 3 minus t plus 1 over 3 plus t. But when you multiply this one, let's calculate this, and what's giving us 3 minus t in the bottom, which is 9 minus t squared. This one multiply this one 3 plus t, multiply this one by 1 plus 3 minus 1 t by 1, 3 minus t. You are going to cancel out here. It gives you 6 over 9 minus t squared. So we'll have only 1. What to do to cancel this 6 to to make it like a 1? We are multiplying by 1 over 6, okay? 1 over 6. Let's put it in the front. It will become 2 over 6, which is 1 over 3, okay? Don't forget, this is the integral, okay? This is the integral, okay? Let's split this whole integral into 2 integrals, okay? Which is 1 over 3 dt, 3 minus t plus 1 over 3 dt, 3 plus t, right? Okay, let's make the negative sign, change the negative sign, and then check the negative sign in the front as well. So our integral become t minus 3. We are not forget minus in the front, okay? Minus 1 over 3. All right. So I integral. What is this? This is natural log. This is natural log. Okay. So our I integral become. Let's start with this one first. 1 over 3 dt over t plus 3 minus 1 over 3 dt over t plus 3. Okay, gives you this one t plus 3 prime. To show you why I'm using natural log, because the prime of the top one, the function, over the function itself. Minus 1 over 3 t minus 3 t minus 3. dt, which is 1 over 3 natural log of t plus 3. Okay, the absolute value of natural log t plus 3 minus 1 over 3 natural log of absolute value of t minus 3 plus constant. I'm using the absolute value because we know the natural logarithm, it has to be positive inside, not include 0. Okay, so our new integral become this one, but we have to switch it to phi, because our original function was phi, not t, right? So let's continue evaluating. And then also, if you take a look at here, we know natural log of a minus natural log of b equal natural log of a over b, right? Let's do it. Let's look into this one. So our integral become 1 over 3 natural log of t plus 3 over t minus 3 plus constant. Let's change it to x now, to phi. So phi equal what? Equals tangent phi over 2. Tangent phi over 2 plus 3 over tangent phi over 2 minus 3 plus, always plus constant. Okay, we finish our integral. Thank you for watching. I see you in next video.